Is the Earth flat or round? It's round. Okay, now let's see. How do we go about proving that? Go to the seashore. Go to a seashore and figure out why you can't, if you live on the East Coast, figure out why you can't see Spain from the East Coast of North America. It looks like you might have a St. Louis hat on. I'm not sure. Just go to the middle of the Mississippi River and look south. Why can't you see the Louisiana? Why can't you see New Orleans? What's the problem there?
Easiest ways that you can prove that the Earth is round, because apparently this is something that we're debating. I have no idea why. That's a hard thing for me to even start talking about, because there are so many proofs that the Earth is round, it's difficult to know where to start. And it's not okay to think that the Earth is flat. This is not a viable argument. I have friends who have been on the International Space Station. They have orbited the Earth once every 90 minutes. You know, I have had personal experience with people that have been up in space and can see with their own eyes that the Earth is round. And of course, we've taken all these amazing pictures from space. They're so beautiful, all those pictures of the Earth.
The fool on the hill sees the sun going down, and the eyes in his head.
So I don't really know what's going on right now with this Earth is flat thing, but I will tell you that this is one of the things I really enjoyed teaching my own astronomy class about, because there are proofs all around you. It is not difficult to know that the Earth is round. In fact, people have known this for way more than 2,000 years. The ancient Greeks actually had a number of really elegant, wonderful proofs that the Earth was a sphere. One of the things you can see yourself with a pair of binoculars is if you actually go out to a lake and there are boats on that lake, the farther away a boat is, the more the bottom of the boat will disappear, and you'll basically just see the mast of the boat. And as a boat goes farther and farther away, the last thing you will see is the very top of the mast of that boat. And that's because the boat is actually going over the horizon that's curved.
If the Earth is 25,000 miles in circumference, there must exist a curvature drop of 8 inches times the mile when you square the mile. 1 mile means there should be an 8-inch curvature drop. 2 miles, 2 times 2 times 8 is 32. That's 32-inch drop. 3 miles would be a 72-inch drop. And this would exponentially continue.
Well, then climb a tower or go to the top of a hill or a mountain, and you'll see a little farther, but you will not see to the other side of the Earth, places we know to exist. For example, I've been to London. I can tell you, other people have. I've been to Vancouver, British Columbia, and you cannot see Vancouver, British Columbia from Boise, Idaho, let alone from New York City or Toronto or what have you. Just start there. Then if you'd like, look at pictures from space where you see the Earth as a sphere. Those pictures are not faked. And I'll tell you, just if nothing else, here's why you can tell they're not faked. Just to create the paperwork that NASA has created, NASA in this one case, just the paperwork to send anything out in space, to send people into orbit or to send them to the moon, that amount of paperwork would make faking it prohibitively expensive. No one could afford to generate that much documentation. Then the other thing, if you want to get into this, if you're really serious, if your friends are really serious, have them get on a boat or a ship and go out at sea, and you'll notice you can't see infinitely far. Furthermore, if you get into it enough, pick up a book about navigation or go online and learn about navigation. A very, very important thing you have to take into account when you try to navigate the ocean from a ship or a boat is how high you are off the sea surface. The higher you are off the sea surface, the farther you can see, the farther away the horizon is. But spend some time learning about navigation. Tell your friends to spend some time learning about navigation. Navigation's changed the world, by the way. What are you wearing? You're wearing stuff that came from another part of the world on a ship. It didn't get here by magic. It got here through science.
And the tropics are places near the equator of the Earth where sometimes the sun is overhead in the sky. And this was actually something that the Greeks used not only to prove that the Earth was round about 2,000 years ago, but they actually measured the circumference of the Earth accurate to within just a couple percent. 2,000 years ago, we've known that the Earth was round. There was a really brilliant Greek scientist called Eratosthenes. And Eratosthenes noticed that there was a town called Syene. And on a certain date, the sun would actually shine straight down to the bottom of a well. That meant the sun was directly overhead. You could look down a well and see the sun shining back at you. And on the very same date, farther away in the city of Alexandria, that didn't happen. The sun was not directly overhead. It was a slight angle. And all that Eratosthenes did was he measured the difference in the angle of the sun. It was straight overhead in Syene. In Alexandria, it was a little bit less than overhead. And he rationed that that change in angle from one city to another was probably indicative of us being on a curved surface. And you could make all kinds of measurements even between those two cities and see that the angles were different. The sun was at a different place in the sky. Using this, he actually measured the circumference of the Earth, and he got it right 2,000 years ago. So another really simple proof is that on any given date, at different cities and different places around the world, the sun is at different angles in the sky. That wouldn't happen if...
How can we use this observation to see if Earth's surface is curved? We needed another well. Turns out we can't see the bottom of both wells at the same time. What might explain this? Well, there are two possible explanations. First, we could have a flat Earth with the sun that's small and close by, so that the light hits the second well at an angle. Or second, we could have a curved Earth with a sun that's big and far away, so that all the light comes in parallel, but only one well at a time is lit all the way to the bottom. Turns out with just two wells, there's enough wiggle room for both explanations to fit our observation.
Then there are some other proofs that are a little more obscure, but they're actually really lovely. And one is to observe what happens during a lunar eclipse. Now, a lunar eclipse happens when the Earth casts a shadow on the moon. The moon actually goes dark. In fact, if you've seen one, you can actually see the Earth's shadow go across the moon. And when the moon is entirely in the Earth's shadow, the moon looks kind of dark and even kind of red colored.
Lunar eclipses. What's a lunar eclipse? If your face is the brilliant sun.
Thank you.
And this is Earth, and the moon is over here. The sun is always casting Earth's shadow into space. It's always there no matter what.
Right.
Obviously, okay? It's just a shadow.
It's a shadow.
The moon
It's just a shadow
occasionally...
shining on blackness.
yeah, a shadow in darkness.
A shadow in darkness.
So the moon occasionally passes through that shadow. And if you see the shape of Earth's shadow on the moon, it is always round. Always round. If Earth were flat, sometimes you get like a flat shadow.
Right.
We've never seen a flat shadow.
Right.
In fact, it is a segment of a arc of a circle, no matter the orientation of the moon and the sun. And the only thing that makes a perfectly circular shadow...
Every different vantage point, every different angle that the sun is casting a shadow, you always get a perfectly curved shadow. The only shape that can cast a shadow that's curved from any direction you put the light is a sphere. So people have known that the Earth is spherical for thousands of years. It's not okay to say that the Earth is flat. This is some sort of strange denial. I don't know where it comes from. And it's something where I keep getting this question. we really need to put this question to bed because we've known the Earth is a sphere for a long time.
Oh my. Now, this discovery that the world is round was made in 15, it was published in 1540. Now, I'm concerned, it was Copernicus. I'm concerned it might have been 1530, but it was about then. It was in the 16th century that the Earth was shown to be a ball. But it was known to be a ball by a lot of other people before Copernicus in the Western world, what we now call the Western world, Western Hemisphere. The ancient Greeks noticed that from time to time, the Earth casts a shadow on the moon. This is a lunar eclipse, where the moon gets in the shadow of the Earth. The sunlight is being blocked by the Earth, the moon's on the far side of the Earth. And that shadow is always curved. And the only shape that always produces a curve, no matter what the orientation, that is to say, whether you're standing in Greece at night, or if you're standing then 12 hours later in Buenos Aires at night, the curve, the shadow is always curved. So the ancient Greeks knew that the Earth was a ball. They didn't know to the degree of the size of it, to the degree of precision we know now. And you guys, come on. Everybody watches newscasts. You all use mobile phones. You all see airplanes fly around. You all go to see Ed Sheeran in concert one day in London, another day in Melbourne, Australia. This all depends on our fundamental understanding of the size of the Earth and its shape with extraordinary precision. And if you want to get into it, the Earth isn't quite a sphere. It's a little bleh. Its spin is a little bleh, stretched it, made it slightly oblate, as the saying goes. This is all susceptible to analysis. But
So you want to find the farthest point from that center. And it turns out sea level at the equator is farther away from the center of the Earth than sea level near the poles. It has nothing to do with global warming and melting of the ice caps.
Why is that?
Because Earth, we know it spins once a day. Yes, thank you. 3 people know how long a day lasts here.
Good for row number 2. They're off to a great start.
So you spin, when you spin pizza dough, it kind of flattens out.
Yeah.
Gets wider in the middle. And so Earth, throughout its life, even when it formed, it was spinning. And it got a little wider at the equator than it does at the poles. So it's not actually a sphere. It's oblate. And officially, it's an oblate spheroid. That's what we call it. But not only that, it's slightly wider below the equator than above the equator.
A little chubbier.
A little chubbier.
Yeah.
Chubby's a good way. It's like pear-shaped.
Yeah.
So it turns out the pear-shapedness is bigger than the height of Mount Everest above sea level.
How much higher is the tall mountain that you identify in this book, which name I forget, and probably you do too, in Peru, or is it Ecuador?
Ecuador.
Ecuador. How much higher, if you were on top of this mountain in Ecuador, how much higher than the Mount Everest would you be?
There's a 20,000-foot mountain in Ecuador, which is right. Ecuador is like near the equator, hence Ecuador.
Oh, you're just not giving up.
And that mountain is actually, the summit of that mountain is 1 1/3 miles higher away from Earth's center than the summit of Mount Everest.
Okay. Question number 2.
But wait, but you got to know, let me just so you understand. We've been fed a lie our entire, I want to call it a lie. We've been fed.
It's a point of view thing, I think.
Earth has been misrepresented to us by geologists because the globe